So the last sum is agglomerative hierarchical clustering. If you watch the k-means clustering, the difference between that and this is, in k-means you refer to different centroids initially, but in hierarchical clustering you start with one individual point and then you keep clustering at each step, merging the closest pair of clusters together. So the sum will give you 6 points with their x and y coordinates, and you need to find out the Euclidean distance of each point with every other point. So once you've done that, you get a different table. If you know how to get Euclidean distance, you end up with a table like this where the diagonal elements are 0 because the distance between a point in itself is 0. And then for each x and y coordinate of P1, P2 and P1, P3 and P1, P3 and P2, you should calculate the distance. So this is the initial preparation that you need to do for the sum. Then the type of hierarchical clustering we're doing is called single link clustering or minimum clustering. Why we call it minimum clustering is at each step you keep considering the minimum values that you get. So step 1 would be to find the minimum in this table. So I'm going back to this. In this entire table, 0.11 is minimum at 0.6 and 3, at the intersection of 0.6 and 3. So the first step would be to find the minimum. The second step is merge these points. So P6 and P3 are the minimum. So I merge them together. I have P1, P2, P3 and P6 are merged in the row. Even in the column, P3 and P6 are merged. So once I have merged them, you have to copy the elements except for this P36 row. So how do I generate this new table? P11 remains as 0. P12 remains as 0.24 as seen above. But for P1 with P36, you refer to the above table where P3 and P6 are given. You write the minimum number. This is why this is called the minimum method. So between P3 and P6 you have 0.22 and 0.23. You copy the point 0.22. So P1, P4, P1, P5 remains the same. Then P2, P1 remains the same. P2, P2 remains the same. But for P2, P36, go here and see P2 is here. P3 is 0.15. P36 is 0.25. So 0.15 is the minimum. You write 0.15 there. Copy the rest of the table as it is. Then you come to P36 row. Okay, P36 with point P1. So point P1 is here. P3 is 0.22, P6 is 0.23, which is the minimum of these two, 0.22. So you write 0.22 here. Cool. Then you come to P36, P2. 36 with P2. Here it is 0.15 and 0.25. What is the minimum of these two? 0.15. So you write 0.15. Again with point P4. With P4, P3 is 0.15. P36 is 0.22. 0.15 is the minimum of these two, so you write 0.15. Similarly, for the last row between 0.28 and 0.39, 0.28 is the minimum. The formula is here. dP1, P36 is equal to minimum of that point with the other point, which with 3 and 6. That was so abrupt. Okay, so the distance of P1, P36 is the minimum of D P1 P3, D P1 P1 P6. So this is for P1 P36. Yeah, so between 0.22 and 0.23 you get 0.22. Same formula, apply it to everything. So after you've done this, you repeat the first steps again. Find the minimum of this. So the minimum of this is 0.14 and 0.14 again. So that's at P2, P5, right? P5 and P2 are intersecting at 0.15. So what is your next step? It is to combine P2 and P5 just like you did with 3 and 6. Voila, that's done. So you have P25, you combine it with P1. How do you find this value? Same, use the minimum formula. So under P1, I need to check P2 and 5. So P1, P2 is 0.24, P5 is 0.34, obviously 0.24 is lesser. So I write 0.24 here. Same thing you do for the entire thing. You guys have come till 7th semester, you'll know how to do it. Find minimum. After you make the entries, find minimum again. So here you can see the two minimums are 0.15 and 0.15, but they lie at different points. So the next, I can either combine P36 with P25, or I can combine P36 with P4. both will give you the same result in the end. But I've combined P25 and 36 because why not? So take either, no difference. So after you combine that, you need to recalculate the distances again. 0.22 and 0.24, the minimum is 0.22, so I write 0.22. Then between 0 and 0.15, 0 is the minimum, so I write 0. Only these two values, rest everything is the same. So now again 0.15 is the minimum between 2, 2, 5, 3, 6 and 4. So I combine both of this, I end up with this, and then you need to combine this, so you end up with nothing. So this is the heuristic hierarchical clustering. Once you're done with that, they might ask you to draw a single link clustering diagram. So this diagram looks like some topology shit. What you need to do is, the first thing that we combined, if you see here, is 3, 6 was the first row and column that we combined. So combine P3, plot the graph, okay, you'll know the value of P3 and P6. Plot them, circle them, write 1. The next thing we combined was P25 and P2 and 5. So circle them, make it number it 2. Then we combine 2, 5 with 1, 6, circle that and write 3. Keep circling till you circle everything. The world is round. After you've drawn the circle stuff, I mean the topology single link thing, you need to draw a diagram called Dendogram. So Dendogram is the same diagram that you drew with a different graphical representation. So first we combine 2, 5 and 3, 6, right? So you combine 3, 6 in the graph and then you combine 2, 5 individually. Then you combine both of these together. So at what point did you combine both of these? As 0.15. So connect both of them to 0.15. Then this you combine with something else, blah, blah, blah. Follow the rules, so they're in the textbook. All the best.